Oops. Okay, so we're going to talk about solving equations. All right, so an exponential equation, right? Let's start with exponentials, then we're going to go to logarithmic. This is when you have an equation with basically exponents in the variables in the exponents, right? And they can essentially look like this first case where only one of the terms has a variable exponent. Or it can look like this, where both of the terms are on either side of the equal sign have a variable exponent. Okay. So to do these, we use what we call one-to-one property, which means if you've got the same bases raised to an exponent, then you can just assume that the exponents are equal to each other and solve it that way. So let's start with that one here. The first example, I have 4 to the x plus 2, 16 to the x minus 3. I can write both of those in terms of the same base, right? So here I have 4 to the x plus 2. I can leave it that way. And then the 16 can be written as 4 squared times x minus 3. Now that the bases are the same, I can just set the exponents equal to each other, and it becomes, like a cute little algebra problem. So I get that x is equal to 8. Okay? Now, what is the domain for all exponential functions? All real numbers. So you don't really have an issue of extraneous solutions for these, right? Okay. So take a look at the next one. I have 2/3 and 9 to the 4th, right? Well, okay, so 2/3, I can't really do much with that, equals to, okay, 9/4, okay, that's the square of this, but it's also the reciprocal, right? So I would have to write that as 2/3 to the power of -2 times 3x/4. So now I have x minus 5 is -2 times 3x/4. These go away. X minus 5 is -3x/2. If I cross multiply, 2x minus 10 is -3x. And then I have 5x equals 10, x equals 2.
Wait,
right?
To cancel the -3 and the 4.
Not the -3, the -2 and the 4.
Oh, it was -2.
Okay. Yep. Yeah. Okay. And please, guys, if you have a question, raise your hand so I'm not interrupted. Okay. Now take a look at this. This one, you have the exponent only on one side, right? You have the variable exponent only on one side, right? So what you're going to do in this case, variable is on one side. You have to do the inverse, right? Which is a logarithm. What's the base of that power? 4 to the x. What's the base? 4. So you have to take log. All right, I'll write it here. So it has to be log base 4 of 4 to the x equals both sides, right? Log base 4 of 13. So now we know that on the left side, I just get x is equal to log base 4 of 13. Now, if this is a non-calculator section, this is a perfectly acceptable answer, right? If it's a calculator section, you plug it into the calculator and you're going to get about 1.850. Okay. Now, for the next one, now again, I have a power equal to something. What's the base of this power? Yeah. E. Did you have a question?
Yeah, I was just wondering, is there a specific amount of decimal places you want us to go to? Or
It'll always be specified. Usually it's like 3. So this base is E. The log base E is just ln, right? So I take ln of both sides. I get 2x plus 1 is equal to ln of 8. And now I have to subtract 1. So I get 2x equals ln of 8 minus 1. Please remember, this cannot be ln of 7, right? It's ln of 8 minus 1. Then I need to divide everything by 2. So x is ln of 8 minus 1 all over 2. And then you guys know how to put it in decimals if you need to. Okay? Okay. Right. Yep. Okay. Sure. Yeah. Okay. So let's talk about logarithms. Okay. Logarithmic equations, it's the same thing, right? So we can still use the one-to-one property. Basically, if you have an equation like this, where you see how you have log base 2 of something equals log base 2 of something, if the log and the base is the same, then you can set the argument, we call it, the stuff inside equal to each other. So take a look at this one. Okay, so again, you have to look at, do you have a logarithm on one side or do you have a logarithm on both sides? In this case, you have it on one side. You first have to isolate the logarithm. So you get ln of x is equal to 9. Okay, now, take a look. You have a logarithm equal to something. So now let's go back to our question. What is the answer to a logarithm always? An exponent. So this is the exponent. Every exponent needs a base. What's the base in this logarithm? E. So I say x is equal to e to the 9. All right? And usually, like, e to the 9 is too big a number. We don't even go to decimal. So the rule of thumb, if you have a power, like something to the power of something, if you're in the hundreds, right, if the answer is in the hundreds, it's fine. But once you get into the thousands, we just leave it as the power, okay? Again, the older we get, like the deeper we go into math, it's not about like that final numerical answer, right? It's about like the expression and everything that leads us there, okay? All right, so we're going to subtract 7 here. So we're going to get negative 3 log 10x equal to 6. Divide by minus 3 gives me log equal to negative 2. Now, again, I have a logarithm equal to something. The negative 2 is the exponent, right? What's the base of this logarithm? 10. So now I have this inside equal to 10 to the power of negative 2. Okay? Okay, let's move on. I'm going to answer your question right now. So now we're going to divide by 10. We're going to divide by 10. So what I get here is x is equal to 10 to the negative 2 over 10. So x is 1 over 10 cubed, right? So 1 over 1,000. Okay? Now, more often than not, students will say, okay, this has a base of 10, log 10, 10 cancels. No, because this here isn't just a 10. It's 10 times x. So it's a more complicated term. So you cannot cancel like a 10 from the base anymore. Okay? All right, let's move on. Here, now I have a logarithm on both sides. You see how they're identical logarithms? I can set the insides, the arguments equal to each other. So I get x squared plus x equals 20. Oh, look at that. It's everybody's favorite quadratic function to solve, right? Bring it over. Set it equal to 0. You factor. X equals negative 5. X equals 4. Okay. What's the domain of logarithms? Is it all real numbers? No, right? Because it's got a vertical answer, a vertical asymptote. So we can get extraneous solutions here. So anytime, especially when you've got a situation like this, you should always go back and check, right? So let's check. If you have x equals negative 5, plug it in here. Log base 5. And then if you put negative 5 in there, you get what? 25, 20.
Wait, log base negative 5 though, right?
No. You put the 5 is x, so you put it in for the x's. You're going to just put it in that problem. Log base 5 of 20 equals that, so that works. Does x equals 4 work? Yeah, that works as well. So both of these are solutions. Okay?
Wait, sorry, so I just don't understand, like, why do you not put the negative 5 in the base? Because
Okay, because the base is already the base. It's part of the problem. What you've gotten is a value for x. So you can only substitute for x, not the base.
Oh, I get it.
Okay. So, yep.
Why are we still checking this one and not like?
Because the domain for logarithms is not all real numbers, but the domain for exponentials is all real numbers. So here you can get values that are out of the domain. Okay, for exponentials, you will never get a value that's out of the domain. The only thing is you might just make a mistake and you get the wrong answer. Okay, all right. Here, we have a problem here. You have a logarithm on one side, but 2 on the other side. So first you have to condense. So the first part stays as it is. But here, I get log base 2, like we did in the last section, 10 over x minus 4. Now, you set these equal to each other. Okay? And then again, it becomes like an algebra problem. 5x minus 20 is 10. 5x is 30. How much is x? 6. And then you have to check if it works. To check, you have to plug it into a step before you got rid of the logs. Like if you plug it in here, it obviously works, right? That's an algebraic function. So you have to plug it either here or here. So let's go here. This is log base 2 of 10 minus log base 2 of 2, which is what? You can divide those, right? Log base 2 of 5. Okay, so if you plug it in here, what do you get? Log base 2 of 5 equal to log, oh no, sorry. I meant not in here, but in here. Log base 2 of 10, why don't I have enough room? Okay. Log base 2 of 5 equal to log base 2 of 10 minus log base 2 of 8. I'm sorry, 6. Sorry, I gotta slow down. I'm just too excited because the next page, I love the next page. See, I'm just so, I'm so anxious to get to the next page because I love that one. Okay? Now, what is this though? Log base 2 of 10 over 2, which is 5, which is the same. Okay? Yep. Okay. I'm actually going to come back to this one because it's kind of an isolated problem. Okay. Let's go here. These are the ones I love. Okay. Huh? Okay. So now here we have an issue. The issue here is we have powers on either side, but they're not the same. And there is no way I can write 3 or 2 in terms of the other, right? Like we did in the first page. So here we have to do something different. What we have to do is take the ln of both sides. Okay? So take a look at what happens here. Oops. ln of 3 to the power of 6x minus 3 equals ln of 2, 4 minus 4x. But what did we learn about exponents is they can come down and become coefficients, right? Okay. So this becomes 6x minus 3 ln of 3 equals 4 minus 4x ln of 2. Don't forget the parentheses. Okay, so now we distribute. Okay, distribute. All right, 6x ln of 3 minus 3 ln of 3, 4 ln of 2 minus 4x ln of 2. What strategy would you use that next? What would you do? Huh? We don't want to condense because they have like different versions. So basically what you want to do, you're solving for x, right? You're going to bring everything with an x to one side and everything else to the other side. So 6x ln of 3 plus 4x ln of 2 equals to 4 ln of 2 plus 3 ln of 3. What are we solving for? X. So let's factor out an x from the left side. So I get 6 ln of 3 plus 4 ln of 2 equals this. Okay, we're still solving for x. So what would you do now? We're going to divide by all of this. Okay, so x is this, but this is not simplified. We're not dividing LNs. We are just, this is x times a term, x times a parenthesis. You can always divide one factor by another factor. That was a different thing here. What you had here was something plus something, and then you just brought them underneath. So that was a different situation, okay? Okay, so now look at this. This is not simplified. So you have to simplify this. Each of these coefficients have to become exponents. So this becomes ln of 2 to the 4 plus ln of 3 cubed over ln of 3 to the 6 plus ln of 2 to the 4. Now you can condense even further. How can you condense these? Ln of 2 to the 4 times 3 cubed, ln of 3 to the 6 times 2 to the 4. Okay? Nope. We cannot simplify. We cannot cancel those two with each other because they're inside their respective ln's. All right? And now, like that would even be, for example, you know, like in the book, it might say like ln of like 432 divided by blah, blah, blah. But as I just said, once you get into the thousands, I'm fine leaving them like this. Okay? So that's the final answer. Okay, let's do another one of these. All right, you tell me. Raise your hand if you think you know. You see a problem like this. And now we need to see what the first step is. So if you think you know what the first step is, raise your hand. First step, yeah. Right, ln. And then we're going to use properties of logarithms and bring down the exponents. This stuff, like in the beginning, it might seem complicated, but if you just do a couple, it really, like, you just have to kind of get used to this. So 2x plus 4, ln of 6, negative x plus 1, ln of 5. Okay, raise your hand. What next? Raise your hand. Distribute, okay? So we're going to get 2x ln of 6 plus 4 ln of 6, negative x ln of 5, 1 ln of 5. So now I'm going to wait again for somebody to raise your hand and tell me what is the next step. Next step. So, sorry. Say it again. Bring, right. Oh my God. Bring all the x's to one side. So 2x ln of 6 plus x ln of 5, ln of 5 minus 4 ln of 6. So look, I always like when I'm going to bring the 4 ln of 6 over here and I'm going to get a negative, I always like to make that the second or third term so I don't have like a negative outside. It's always like cleaner. Okay, now we're going to factor out an x. Now we divide. ln of 5 minus 4 ln of 6 over all of this. Okay? So what do I get? Here. Okay, so let's simplify this now. X equals. In the numerator, I have ln minus ln, which is going to be a division, right? So I have 1 ln 5 over 6 to the 4. Okay, so it's okay if you want to take more steps, but it's also okay if you want to do it this way. Here, the 2 will become an exponent, so it's ln of 6 squared times 5.
And if it was a minus.
Okay, hang on, please, hang on. So right here, okay, so I have like ln of 5 over 6 to the 4, and then this will be like ln of 180, right? So sometimes like we'll just simplify that, okay? Now, before I take questions, when you do these in the book, right? I'm sorry, when you do these from the book and you're checking your answers in the back of the book, if, like for example, like here we brought these to the left and the other ones to the right. If you did it the opposite way, you know how like the negatives will be opposite? Okay, in ln's, when your negatives are opposite, what will happen is, instead of like ln of 5 over 6 to the 4, you might get 6 to the 4 over 5. So this will be a reciprocal and this will be a reciprocal. It's like two negatives canceling each other out. So just watch out for that when you're looking for answers in the back of the book. Okay, yeah.
Would it have, like, it wouldn't have changed if it was like 2 ln of 6 minus ln of 5. It still would have been like the same answer.
No, then it would have been divided by it. It would have been, then it would have been ln of 36 over 5.
But for this, like for that homework problem, like we multiplied the ln, the y.
Because you had two, let's do this later. Because here you had two terms with negative. Let's do that later, okay? All right. Okay, so take a look at this one. Okay, this is like a completely different one now. So remember, okay, quadratic form, right? I'm just going to write this here. You don't have to write this, but when you have something like this, how do you know that you can factor it with the 2 parentheses? We've kind of been over this because you've got the constant, a variable, then the square root of the variable, right? The variable squared. Look at this. We have the exact same form here. We've got a constant, something with a variable e to the x, then that term squared, the square term of that, right? That tells us we can factor in quadratic form. But now, instead of doing x and x, we're going to have e to the x, e to the x. Because when you multiply those, you get e to the 2x. And then, so this is going to be minus 2 plus 1. Now that you have two things that equal 0, I can take this one, set it equal to 0. And this one, set it equal to 0. So for the first one, e to the x equals 2. I need to take ln of both sides. X equals ln of 2, that's good enough. Okay, here, e to the x equals minus 1. ln of both sides. X equals ln of minus 1, which is what? Huh? Not possible. So throw that out, so you only have ln of 2. Okay? Because you can never have ln of a negative number, because like no exponent to the power of something will be negative. Okay, go ahead and quickly do the next one. I'm going to give you like a minute and a half to do the next one. Did anyone not get that? Okay, so here for x, we do get ln of 6 over 0.6. You have to simplify that. So, okay, this particular problem might be like on a calculator section, and it'll be 2.986. Okay, this one we have to condense here. So it's going to be ln of 7x plus 3 over x plus 1, ln of 2x. Set those two equal to each other. Okay. And then let's go ahead and solve. So when you cross multiply, you get 2x squared plus 2x equals 7x plus 3. Bring it over to the same side. Okay, we're going to factor. We're going to do guess and check because we're going up now. Okay, 2x and x. I have a 3 that I can only split up as 1 and 3. So if I try 3 and 1 like this, okay, then I get 2x and 3x, and you think that will work, except it doesn't because the signs don't work out. But if I do 1 and 3, then it does. So now I get 6x. So if I make that a negative, I get negative 6x plus 1x. So x is negative a half, x is 3. Should you check that? Yes, I'm going to leave that up to you guys. All right. Okay, I want to do this next thing too, and then I will stop here since we have like a day and another day. Let's just take our time. Okay. Okay. This is another thing that just comes up. You learn how to do it when you're like really little, and then by the time you're in calculus, everybody just expects that you just know it because you learned it, right? But then we forget. So let's just remind ourselves. You have something like this, you are expected to be able to do this by hand, right? So another way of writing this is the square root of, okay, so look, you can write it like this, 27 cubed. Or this is also the same as root 27 cubed like this. And depending on your preference, right, what's easier for you to solve, you can take one or the other. So let's just take the second one here. Root 27 is 3 root 3. And now I need to cube that. Okay? So essentially what you have here is 3 root 3 cubed. Right? So you can see these 3's, the coefficients, will be 27. These two will be another 3, and then you have another root 3, right? I mean, and then that'll be 81 root 3. So that's one way that I reason it out. That's one way that I would do it. Well, is there like somebody else whose brain will reason it a different way? Of course, like if I give you, like 27 plus, I don't know, 35, each one of us counts that differently, right? So of course, like however your brain likes to rationalize this. Okay, yes.
Could we change like the 27 to like 3 root 3?
Well, that's what we did.
Oh, sorry, I meant like 3 to the third.
3 to the third. Yes, you can do that as well. Yep. Okay, so here I have root 12 to the 5th. What'd you call me? Sorry, I was just joking. What other way?
There's 2 ways to do it.
Oh, yeah, so this one is 27 cubed. That obviously you can't do in your mind. But if you change this to 3 cubed, then it'll be 3 to the 9. And then you can take a cube root of that. Okay, so this one, like root 12 is 2 root 3 to the power of 5. And then remember, the 5 belongs to both of these, right? And 2 to the 5, what is it these days? 32. 2 to the 6 is 64. And then root 3 to the 5. So you have 5 of these, right? Each pair will become a 3. So again, 3 times root 3, that's 9 root 3. And then you even have to do that in your head, right? 9 times 3, 270, 288, root 3. Yeah? We'll stop here for today.